So let's talk a little bit about the file system interface. And by interface, what I mean here is how your application accesses data or accesses files. We'll talk about POSIX, and that's probably the way that you've become accustomed to working with your data, at least thus far. It stands for Portable Operating System Interface, and it's usually for Linux or Unix variants, although certainly can apply to some of the Unix-like portions of the Mac operating system, and can also be sufficiently general such that even some various operating systems can try to match those interface standards. It's a family of standards. It's an IEEE standard. It's broad in terms of the operating system. It's not just file systems. We're going to focus here on file systems. And specifically, when we talk about a POSIX compliant file system, it behaves in a way that we would expect our application to be able to go through a hierarchical file name resolution so that we can go up directories, down directories. If we're going to give a file input to our application, we should be able to give a path. What is a path? A path expects some sort of a file hierarchy there. We can set Unix permissions. We can set permissions for individuals or groups. We can create symlinks so that we don't have to have copies of it everywhere. We can have a file at one location in our file structure and put links for various purposes in different locations. Open and close, we can talk about when a file is allowed to be opened and closed by the application and when it has to be, renaming it, and then reading and writing, how you can pull inputs and push individual segments of your data out to the file when you're trying to write it. So we'll give a few examples that you may encounter the POSIX file systems when you're doing scientific computing. Specifically, we'll look at the network file system, Lustre, and Panasys.